Hi folks, this is Steve with Disruptive Software. In Chapter 1 of the iCanScript Space Shooter tutorial series, we're going to learn how to move the player spaceship, how to keep it bounded within the screen region, and how to apply tilt for a more realistic motion. Begin by launching Unity with the iCanScript Space Shooter package as downloaded from the iCanScript website. Make sure to use the empty scene, as can be found in the root scene folder, so that we can create all the visual scripts from scratch. We're going to start by adding motion to the player spaceship. Select the player game object and click on the Inspector tab. As you can see, the game object has already been set up for you. If you would like to learn how to do this, these aspects are explained in the Unity Space Shooter tutorial found on the Unity site. Now click on the Visual Editor tab. As we can see, there is no visual script yet. Let's add one. Scroll to the bottom of the player inspector and click on the Add Component button. Select iCanScript, and then select Visual Script. We are now looking at an empty visual script with a default update message handler node already added for us. If we don't need the update node, we could always delete it. In this case, we will use it to read the game controller. iCanScript offers library nodes to facilitate building games. Let's try and find a game controller. Click on the Library tab, and we can see that there are folders for functionality offered by iCanScript, .NET, and Unity. In this case, we will use the iCanScript game controller, so unfold iCanScript. Here, we can see there are library nodes for various areas such as logic, math, variables, time, etc. Let's look in input. Here is a game controller, and there are two. One that offers analog and 3-button, and another offering more functionality. Let's use a simpler one. Just click on it and drag it into our update node. Scale will affect how quickly it will react to our inputs. 10 is a good value, so let's change it to that. Go back to the inspector, unfold the ICS Visual Script node, and enter 10 for scale. There we go. Now we will need to use the game controller output to control the movements of the spaceship. Let's do this in the Fix Update message handler. From Unity functionality, Fix Update is called on a fixed frame rate, allowing more consistent motion even if the frame rate drops. However, we should do as little as possible on Fixed Update to not slow down overall performance. To add a Fixed Update message handler, right-click with the mouse over the Visual Editor canvas, the blue area, and select Fix Update. Now we can see two message handler nodes. The rigid body component allows us to control an object's position. So let's pull out the instance node. To do this, click on the player rigid body port, drag it into the Fix Update node, and release. Select rigid body instance. We now have an instance node. We will need to change the velocity, so let's expose a velocity input port. To do so, select the rigid body node, click on the instance tab, and we can see that there are variables and operations that can be selected. Let's find the velocity variable. Just scroll down and find it in alphabetical order. Here it is. Let's click the In box, and here the port is in our node. Now we will need to translate the game controller vector2 into a vector3 velocity. Let's create a small package to do so. In Fix Update, right-click and select Package. Let's rename this package. Select the package, click the Inspector tab, and let's type Move Spaceship in the name box. Here is the package now with a more descriptive name. This package will take the analog port of the game controller as an input and output a velocity to rigid body. Let's drag the ports to the perimeter of the Move Spaceship package as such to add the bindings. Let's just move a few things around so it looks cleaner. You can press the L key while a port is selected to help straighten out the bindings. This does not affect functionality but makes it easier to visualize. Now, let's add the details to translate the vectors. Click on Analog 1 and drag it into the package. Float over iCanScript, then float over from to to, and finally click on the From Vector function. What we have done is a way to select from all possible library nodes for this type, which is a convenience over finding it in the Library tab and connecting the ports. Now, let's do the same for velocity. Drag the port into the package and select iCanScript, from to to, and to vector. Now connect the x-axis and the y to z as such. So now we should have everything in place to move the spaceship with the game controller. Let's see if it works. Just hit run up here and use a game controller or the arrow keys. Yep, seems to work. Except we're able to move the spaceship right off of the game area and even off of the screen. We will need to add boundary control to keep it contained. Let's fold the Move Spaceship package since we no longer need to view the details. For the boundary control, let's start by adding a package called Bound Spaceship, where we can implement the functionality. Bound Spaceship will constrain the position of the rigid body, so let's add input and output positions to the player rigid body using the instance wizard. Let's flip the sides of these ports. And let's add bindings to the Bound Spaceship package by dragging the position nodes to the perimeter of the package. This time, to work on the details of the package, let's set the Bound Spaceship as the root node by pressing Ctrl and double-clicking on it. This will allow us to focus on the inner details without seeing the rest of the script. We will use the Unity clamp function to do the bounding, so let's find this using the Library tab. Just type clamp in the search box. Here it is, and we want the one for the float. Let's drag two of them into the package, one for right-left bounding and one for top-bottom bounding. Now, let's expose the XYZ of the input and output vector 3s by dragging them into the package and selecting the iCanScript to and from vector 3 functions. At any time, we can press the F key while the package is selected to refocus it if it grows off the screen. Let's do the binding connections. X will go through the right-left clamp. Z will go through the top-bottom clamp. And Y will go straight through. Now, let's pull the min and max value ports to the package perimeter so that they can be set up without going into the details within the package. Let's give them appropriate names by selecting the ports and typing the names in the inspector. We will set right and left to 6 and -6, and top and bottom to 8 and -4 by again selecting the ports and setting the values in the inspector. To go from the root node back to your main graph, just hit the left arrow key up here. Let's clean up a bit. Now, let's test. Yep, the spaceship seems well bounded now. Finally, let's add the tilt. This will take the rigid body velocity as an input and output a rotation to the rigid body. Let's create the ports on the rigid body, create a package called Tilt Spaceship, and add the bindings. Use the instance wizard to add the ports, velocity out and rotation in, and right-click and select Package to create the package. Use the inspector to change the name of the package, and drag the ports to create the bindings. Let's drag these ports down and flip them around first. Now, let's use Control double-click on Tilt Spaceship to work on it without being distracted by the rest of the script. We will use a Euler quaternion to tilt the spaceship, and you can get more information on this function on the Unity script API page. This will operate on the x-axis velocity, and we will use a multiplication factor to make the tilt look realistic. Start by dragging the input vector 3 into the package, and find the getX function under Unity, vector 3. Now, let's multiply x by dragging x and finding mul under iCanScript math. We will multiply by -4. To make it easier to tune later, let's bring it to the perimeter of the package and name it before setting the value. This time, instead of pulling out the multiplication output and finding Euler who knows where, let's search for it using the Library tab. Let's choose the one with x, y, z floats. Connect the multiplication output to z and the quaternion to our rotation output. And let's clean up a bit. Now, let's test and see if it tilts. Yep, all looks good. So, let's summarize what we have done. This time, let's view the visual script in a maximized view. To do so, just click over here and select Maximize. Now, let's center our graph across the screen. Click on the blue area and hit the F key to focus. Also, let's collapse the GameController to show it as a more compact icon. Now, let's go over the logic. On the update message handler called EveryFrame, we read the GameController and store the values that are then picked up on the fixed update message handler that is called on a fixed interval. The Move Spaceship package then translates the two-dimensional vector 2 for the GameController to a three-dimensional vector 3 needed by the rigid body velocity input. The Bound Spaceship package then compares a rigid body position against the bound values and outputs a position to the rigid body input position that will be within the bounds if exceeded. The Tilt Spaceship package gets the velocity from rigid body and outputs a calculated tilt rotation to the rigid body input rotation. Down here we can see the tilt factor set to -4. Thank you for watching, and please join us in the next chapter of the series where we will continue building the Space Shooter game.